Hello folks, how's it going? Mike, coming back at you with another video on college algebra. In this video, we are going to take a look at linear equations, graphs of linear equations, and some related topics to those things. In the previous video, we talked about relations and when is a relation a function, and how we can tell when that is the case. So earlier on in the course, we discussed how to solve linear equations. Linear equations are these things that can be written in the form ax plus b is equal to 0. Well, in the context of graphing linear equations and looking at linear equations as functions, there is a slight difference that we are going to focus on. In terms of graphing linear equations in x and y, a linear equation in x and y is an equation that can be written of the form ax plus by is equal to c, where a, b, and c are some real numbers. There's some constants, not all of them being 0. Well, as we talked about in the previous video, one of the easiest ways to see what an equation looks like in terms of its graph is to solve the given equation for y. So that's what we're going to do here. I'll start by subtracting a times x from both sides, and then I'm going to divide both sides by b. So I get y equals this thing, but I'm going to write it in this form instead: some number times x plus some other number. And later on in the video, we are going to be coming back to this form. Some of you may already know the name for this form for the equation of a line, but in case you don't, we'll come back to that in just a little bit. So this equation right here, when we solve for y, or this thing right here, if you were to graph it, you get a line. Now there are different kinds of lines. I've sketched the 4 main different types of lines that we have here. We have line 1 here, L1, this line in green here. We see that as we move to the right, this line goes up. We have line 2 in blue here. As we move to the right, this line goes down. The white line here, L3, as we move to the right, that line stays at the same height. And then line 4 here in yellow, the line just goes straight vertical, straight up and down. And later on in this video, we will talk about when do we have each of these different kinds of lines and what things are related to these. One very important and one very key feature of any line that we want to know and look at is its slope. Slope, what is it? Slope describes the amount of change in the y-coordinate for every unit change in x. So as we increase x by 1, how much is the y-coordinate changing by? However much it's changing by, that is our slope. So we can find the slope of a line if we know 2 points that lie on the line, since 2 points are all you need to uniquely determine a line. Now later on in the video, we'll talk about other ways that we can determine a line, but for now, we're just going to work with 2 points. The slope, which we usually symbolize by m, of the line that passes through the 2 points x1, y1, and x2, y2, is given by the following formula. Your slope, perhaps you've heard it stated as rise over run. It's also change in y over change in x. And using these x's and y's, it's y2 minus y1 divided by x2 minus x1. Now, just like a couple videos back, when we talked about the distance and the midpoint between 2 points. It doesn't matter which point you call x1, y1, and which one you call x2, y2. It's just important that you keep with the same order of y coordinates. If you do this guy minus this guy for the y's, then you have to do that x coordinate minus that one. You can't switch the order, or you can't use the different order for one as opposed to the other, because then you won't get the correct slope. So let's just see a couple samples here where we calculate the slope of a line given 2 points. So first up, what's the slope of the line that passes through the points 2, -3 and -1, 8? Well, once again, as we said, it doesn't matter what we choose as our x1, y1, and x2, y2, but I'll go x2 and y2 there, and I'll go x1 and y1 there. So, taking these x and y values and substituting them into the formula for slope that we saw on our previous slide here, we get 8 minus -3, and then -1 minus 2. Again, note that I used this coordinate minus that, this y coordinate minus that y coordinate, which means I have to use the same order of x coordinates. This one minus that one. And now we just find what this turns out to be. You get 11 on top, -3 on the bottom, so your slope is -11/3. So what this is saying is that for this line, if I increase my x value by 1, the y value will decrease by 11/3. How about through the points -7, -2, and 3, 4? Again, which one we choose as x1, y1, and which one is x2, y2 does not matter. But I chose to stick with the same kind of thing. I chose y2 there, and x2 for my second point, and then x1, y1 for my first. So when you do this calculation, you get 4 minus a -2, and then you get 3 minus a -7, and that turns out to be, in the end, 6/10 or 3/5. So just a couple basic samples of us calculating the slope of the line that passes through 2 given points. Some of us may be familiar with this calculation. It may not be too much of a new thing there, but maybe for some of us it is a little bit new. So going back to our diagram where we had 4 different kinds of lines here, we saw that we had this white line here, L3. And that line was completely flat. It doesn't go up or down as we move to the right there. So we want to know, what is the slope of a horizontal line? Well, if we just think about slope as rise over run, and we look back at that horizontal line, then we know that since it's not going up or down, the rise is 0. We do go side to side. We do have a run. The line does go left to right in some sense. So since a horizontal line has no rise to it, and the slope is rise over run, the slope, m, is going to be 0 divided by whatever our run is, and 0 divided by something that's not 0 is 0. So thus a horizontal line has slope 0. Another way you could figure out that the slope was 0 is the fact that any 2 points on a horizontal line will have the same y-coordinates. So if you take those points, substitute them into the formula for slope, you would get 0 as well. Looking back here, we also had this yellow line, this vertical line there, L4. What is the slope of that line going to be? Well, that line, it certainly went vertical, it went up and down, so there is a rise to it, but the line never goes left or right. That is to say, there is no run to it. So, again, slope being rise over run, there is a rise, there's no run, so slope is our rise divided by 0. But when we divide by 0, we get something that is not defined. We can't divide by 0. So a vertical line has a slope that is not defined. Another way you could figure that out is by realizing that any 2 points on a vertical line will have the same x-coordinates. So if you were to take any 2 points, plug the x and y coordinates into the formula for slope, you would get 0 on the bottom here, and you would find that it is not defined. 0 on the bottom there. That's a typo there, folks. That's my bad. So when do we have these different types of lines in the sense of looking at the general linear equation that we talked about all the way back at the beginning of this video? For what values of a, b, and or c will we get these different types of lines? And what's the general form for their for the particular linear equation? Well, a slanted line, things like lines 1 or 2 here, then it's going to be, again, something of the form ax plus by is equal to c, where a is not 0 and where b is not 0. C does have the freedom to be 0. Now, again, as you look back at this graph, you can see that for L1 here, this goes up as we go to the right. This means that this line has a positive slope. As x increases by 1, y is going up by some quantity. For line L2 here, the slope is negative. As x goes to the right by 1, the y value goes down by some quantity. So those are the 2 types of slanted lines that we can have, and they do follow that general form of ax plus by is equal to c, where a and b are not 0. Based on the combinations of a and b values that you have, you may get a positive slope and get something like line 1, or you may get a negative slope and something like line L2. The next type of line, our horizontal line, is generally of the form y is equal to some constant. How do we get that from our general form ax plus by is equal to c? We set a equal to 0, and that removes the x piece of it, and then b is just not equal to 0. C has the freedom to be whatever it chooses to. And then lastly, the vertical line. Generally, a vertical line has an equation of the form x equals some constant. How do we get that from our general form here? We make sure that a is not equal to 0, and we set b equal to 0. By setting b equal to 0, we eliminate the y component of that equation. So we already have seen how to find the slope of a line given 2 points, but just knowing the slope is not enough to determine the equation for a particular line. It definitely narrows down the possibilities, but it doesn't give us a particular line. We need one more piece of information. And one of the pieces of information that we can use in combination with the slope to find the equation of a particular line is the y-intercept, the ordered pair 0, b. If we know this and we know our slope, then we can determine the equation of a particular line. And if we're given the slope m and the y-intercept 0, b, the equation for the line is then given by y equals mx plus b. Look back all the way to the beginning of the video when we saw this thing right here, mx plus b. There's a reason that I wrote it in that particular form. And this form, some of you may already know the name for this form, is called the slope-intercept form of a line. So let's find the equation of the line with slope -4 and y-intercept 11. Now, just as a little bit of clarity, and this is something that's commonly done when teaching mathematics. Here in the question, I said y-intercept is 11, but up until now, we've written the y-intercept as an ordered pair. We do those things pretty much interchangeably. They mean the exact same thing. Saying that the y-intercept is 11 means the same thing as saying the y-intercept is the ordered pair 0, 11. So we're given our slope m, we're given our y-intercept b. Let's just take these two values, substitute them into our slope-intercept form, y equals mx plus b, and we're given, and we come up with our line, y equals -4x plus 11. Now, if we're given the slope and the y-intercept, then that's great, because it's really easy then to write the equation for the line. But the fact of the matter is, it's more common than not that we won't be given just the y-intercept. We'll just be given 2 points that lie on that line, and we have to come up with the equation for that line. So how can we do this if we're not given the y-intercept? We can also find the equation for a particular line if we know a point that lies on the line and we know the slope of that line. Those two pieces of information are enough to uniquely determine the equation of a line. So if we know that the point x1, y1 lies on a line and this line has slope m, then here's the other way that we can write the equation for this line. We can write it as y minus y1 equals m times the quantity x minus x1. And there is a name for this form of a line. It is called the point-slope form of a line. You'll probably find that it's going to be a lot nicer and a lot easier to start writing the equation of a line in this form if you are not already doing so yet. If you haven't seen this before, I think most people are going to like this form more. So let's find the equation of the line that passes through the points -2, 5 and 5, 1. And we're going to write this in point-slope form now. So we're told 2 points that lie on this line. We need the 2 points to come up with our slope. Once we have our slope, The other piece of information we need is a point that lies on the line. Well, we're given 2 points. It doesn't matter which one we choose, so we'll just pick one of these guys and use that as our other piece of information, and then we can come up with the equation for our line. But first, I'm going to calculate my slope. I did y2 minus y1, and then x2 minus x1 once again. 1 minus 5 is -4. 5 minus a -2 is a +7. So we get a slope of -4/7. As I said, we can choose either point that we were handed in the problem, but I'm going to use the ordered pair 5, 1, just because it's nicer. There's no negative numbers going on there. What the heck? So, in point slope form, our line is, note, y minus the y coordinate of my point, 1 is going there, equals m, my slope, times x minus the x coordinate of my point, 5. So this is the equation for the line in point slope form. You could then take this and write it in a slope intercept form. If you multiply the -4/7 into both terms here and then add the 1 onto both sides, you would get it in y equals mx plus b form. You may be asked in homework or on a quiz or tests to write it in a specific format. However, if you're not, then I don't care which one you write it in. They are both equally correct answers. So guys, this concludes this video on linear equations. You know, the different types of lines we have, the general form for the equation of a line, slope, how to calculate slope, and the 2 different ways that we can write the equation of a line. If you have any questions or comments, please be sure to reach out to me, guys. Emails, texts, phone calls, snail mail. Shout at me really loud, perhaps I'll hear you. Otherwise, until the next video, take it easy.